Hello, my name's Dan Swain, and today we're going to be talking about the final of the solid principles, the dependency inversion principle. And here we have two parents with their little children or dependents inverted, hence the dependency inversion principle. Okay, now what Uncle Bob says is that high-level modules should not depend on low-level modules. There you go. He says that both high-level and low-level modules should depend upon abstractions, and that's the important thing. Abstractions should not depend on detail. Details should depend upon abstractions. So what does that mean? Imagine we've got our presentation tier, often like a web tier for example, and we've got a direct reference to our business logic, and then in turn the business logic has a direct reference to our data access tier, and this is the traditional free tier application. So what we can say is that our web tier depends on our business logic tier, and our business logic tier, and this is the critical thing I suppose, depends on the data access tier. And we can say that this is for both compile time and also at runtime. So the application will not compile without those references in place, and the application won't run without those references in place. Now what dependency inversion is saying is that your high-level policy or your business logic, that should be in a world of its own, and it should not depend on low-level details like a data tier, which would have a SQL sort of access thing. The data access tier should depend on your business logic. So it's inverted to the previous example. So here we go again. The presentation tier, like the web application, should depend on the business logic tier, because that's, again, presentation is a low-level detail and the business logic is the high-level policy. And here we go. I'm going to draw this again and again. You'll get it eventually. So the old way was that presentation would depend on business logic and business logic would depend on your data tier, and the dependency inverted approach would be more presentation depends on business logic or high level policy, and the data tier also depends on the business logic. Here it is again. Now this is at compile time, so here we have it. We've got data access and presentation depending on policy for compile time, but at runtime it is the normal way, because we can, we have to ultimately, high level policy has to talk to a database to persist. So at runtime it's the normal way. It's sort of about like a boundary. You've got like an application boundary. At one side of the boundary is your high level policy with your abstractions, and then the other side is the low level detail and low level modules like your database persistence and your presentation tier. And this is sort of what dependency inversion is about. It's like saying that your application should be independent of anything to do with sort of talking to a file system or writing to a database. Now people often get inversion of control mixed up here, because inversion of control is not dependency inversion, but it can be used to sort of enable it. So you can imagine that if you've got an iPersist car and a SQL car persister in one DLL or assembly or library, an IOC container can create a new SQL car persister for you. It'll just inject, sorry, got that wrong. Imagine you've got your high-level policy and your IOC container will just inject a new instance of a SQL car persister because it's wired up. But the iPersist car actually lives in the same assembly as the SQL persister. So that violates the dependency inversion principle, because what should happen is that your high-level policy owns the iPersist car's abstraction. So this is what the IOC container is doing. It's basically just saying, I knew up my high level policy, the car, but the high level policy still depends on the low level iPersist car abstraction because it's in the same module. So what we should do to invert the dependencies, we need the SQL car persistor to depend on the abstraction that lives in the same module, or sorry, the same sort of DLL as the high-level policy car service. So that's what we've got on the left, whereas the original one was more the high-level policy still had a dependency on the iCar persister because it lived in the data access tier. And so that's the difference. So you can use an IOC container, but you still have you still have not inverted your dependencies. Uncle Bob basically says a good architecture is a plug-in architecture. If you can imagine, we define our abstraction and then we can plug in a fan or a light or a PC. So that's what it's all about. Thank you very much.